Okay, so let's start with what is MapReduce. Okay, MapReduce is not any programming language, right? So basically, it is a programming model. Okay, so programming model. So in traditional programming, what we do is basically we'll write a code. Okay, so we will have a data and we write a code. Okay, the code will basically read the inputs. So that reading inputs maybe say from any file, or it can be a say example your input file is here. Input, I will say input file, input data. So input data, it can be a file, or it can be a RDB table, or it can be any data. Okay, so the data will be there, and we write some simple program, right? So any programming language, it can be a um, it can be a Java program, or it can be SQL queries, or it can be any C++, C sharp. So you write a program. So when you execute this program, okay, what happens is so based on the logic you written, okay. So based on the logic you written. So example, I'll take this as the execution stage. Okay, so this is program. Okay, so in traditional, the data will be there somewhere. It can be in local machine also, and you write a program and you execute that program. So what it does, it goes and read the input from um, this the data into it'll read the input data, and then it get the data, and it get the data, and it actually applies your logic on top of the data, and it will give the result. Okay, so the result can be uh, um, results can be printing in console, or somewhere console, or maybe writing into another the layer, storage layer. It can be writing a result into DB, or in any even file also, right? So this is how the traditional programming works, right? Traditional programming model works. So the MapReduce, so this is most of the operation or computation happens on single machine. Okay, so the idea of developing a MapReduce is we want to do the distributed computing. So we know that by using a distributed storage, our data is located in the different machines as a blocks. So we need a new programming model which can execute your logic on the different machine. Okay, and then finally it gives the combined output either to your wherever you want to store the data. So by default it stores in HDFS, and there are other way also you can store, like to other NoSQL database, or even local file system kind of things, right? So in general it stores takes the data, input data from HDFS, and write the data into HDFS. Okay, so how this programming model is going to work is, so this programming model is going to use two phase. Okay, high level. Okay, I'll just include. Okay. As a programmer, you will know actually two phase. One is a map phase, Okay, and then you can think, if you want to think in a programming manner, you will think that there is a map task where we can write a logic, your business logic, and there is another method called a reduce method. Just to, if you want to understand in very simple way, that is a reduce task where you can write a aggregation code. Okay, so and then in between there will be a shuffle and a short phase. This is we don't write any code here, but the model, programming model works. There is a inbuilt phase called shuffle and short, because whenever we do aggregation, when you want to do grouping and aggregation, then shuffle will happen. Okay, so this is the uh, core core concept of MapReduce programming. Okay, what happens? There will be a, so when you create a job and submit to the cluster. Okay, so there will be a job client. Job client. Say example, user is sending the. So being a user, you just send your job. It's a command line client, or it can be a using program also you can submit. Okay, you write a MapReduce job in Java or Python, you submit to the job client. Okay, then the job client will submit your job to the cluster. Okay, and it will run in a map and reduce phase. Okay, now, okay, so I'll just pause here, and I will introduce MapReduce related processes. Okay, and then we'll come back to the life cycle of the job. Okay, the MapReduce job. Okay, so I actually we will be focusing MapReduce 2, but still I want to give a little information about MapReduce 1 also. Okay, so that you just theoretically you should know what was happened in the MapReduce 1, which is like in Hadoop 1 version, and that is Hadoop 2. So in Hadoop 2, you have MapReduce 2 version. Okay, so these two we are going to look into that. So in MapReduce 1, what are the process it has been used is basically there is a two main process. One is job tracker. Okay, another is a task tracker. These are the two main process or daemons used. Task tracker. Okay, so what is the use of these two daemons basically, or maybe the what is the role of these two process? As I told you, Hadoop is a master slave architecture, being it a distributed system file system or being it the programming model MapReduce, it's a master slave architecture. So job tracker is the master process. So it takes care of your job initialization and monitoring of your jobs, right? And there is another process called a task tracker, which is a slave process. So which does the actual your execution of your map task and the reduce task, right? So that's how it works, right? So that is so when you say example multiple you submit multiple jobs to the job tracker, so even though it is just doing the kind of uh, a job initialization, or maybe it does the mostly delegate work, right? It's delegating the work, right? So basically job scheduling and job initialization and tracking of your jobs. But still, if the number of jobs goes up, so there is a overhead for this job tracker, okay? And also it is a single point of failure, like as I mentioned in the Hadoop version 1, name node is a single point of failure. If the name node goes down, basically your cluster will go down, right? So similarly, if this job tracker, the where there's a node where you configure a job tracker, if the node goes down, then entire programming model will not work. Your jobs will not run. So to overcome both the overhead of job tracker as well as the single point of failure, so they introduced Hadoop 2 version with MapReduce 2. Okay, so here what is going to happen is they introduce few other process which will overcome these issues. Okay, one is the resource manager. This this process or daemon name is called resource manager, and there will be a node manager. Please stop wherever you need, wherever you have doubt or you want to ask some question. Node manager, and you will have application master, and then you'll have a container. Okay, so these are the process which is going to work. Okay, now all these uh, uh, these are the daemons which is going to use it for MapReduce, but they are part of yarn framework. Okay, so just to just giving you the int. Okay, so these process are comes under the yarn framework. Okay, but the MapReduce 2, it is going to make use of these process, so that what are the problem we had in MapReduce 1 version can be resolved. And the way the MapReduce program works, like map task, which takes your one block data and does the processing and share the result to the reduced task, that process is going to be same. Okay, there is no change in the programming model, but only the daemons which were taking care of this program execution, the program modeling is execution, it's replaced by other processes. But the programming model in Hadoop version 1 or the MapReduce 1 is same in MapReduce 2 also. Okay, so only the processes which is taking care of this MapReduce job life cycle, it's just a process are changed. Okay, that's a difference. Now let me introduce this one. So resource manager, basically what it does is it just knows entire cluster information, right? So entire cluster means it's a master process, and node manager will be in every slave node, but it is act like a master process within that node. Okay, so probably we'll go to, okay, so I will start a new. So I'll just put it in resource manager. Another is the node manager, and application master. these are all like eons framework. Okay, so now okay, when you see this when you build a cluster, so it is going to be a master node. I'll just for simplicity sake, I'll just keep three slave nodes. One is here. Let me see. Sorry, this is node 2. This is a node slave node 3. Okay, so this is being a master node, and this is short name. This is slave 1. This is going to be a SN2. This is going to be a SN3. Okay, so what will configure the daemons for MapReduce model? So there will be resource manager here, RM, and so this is a master process. That's why I'm configuring in the master node. And the node manager is a process which will be configured in every data node, okay, or every slave node. Okay, there will be a node manager 1 here, and there will be a node manager 2 here, and node manager 3. Okay, so this is going to act as a master process within the node, because every node will have a node manager. I will tell what is the role of that. Okay, so then you will have so application master for every application. Okay, so AM for app1. Okay, then you might have a AM for app2. Similarly, every application job you will have one application master. Okay, container is the one which does the actual execution. So how many number of tasks you have, that many number of containers you will have. Okay, container 1 and container 2, like that. So similarly, so on. This is how the process will be uh, uh, configured. Okay. Now we'll go back to the flow of MapReduce job, right? Okay. So what happens? So we'll take example of the same example as yesterday we took, where I have sample1.txt, which is of 250 MB, which is been actually converted into two blocks, and one is 128 MB based on the block size, and another one is 222, sorry, 122 MB. Okay, block 2. Okay, so the MapReduce, what happens is so you will so in the MapReduce model, it is going to be taken this as one input split. I told you block and input split almost both are same except the logical boundary. This is going to be a one input split. Input split 1, and this is the another is the input split 2. Okay, you will have a two input split. Okay, so so you will have two mapper will be running for your input split. Why? Because how many number of input split you have, that many number of mapper will be running. Okay, so okay, now we'll go to the MapReduce the programming model. Okay, I'll just show you one diagram. Okay, so this is we'll just consider one one block. Say they will take example of this input split one. Okay, so how the MapReduce works is MapReduce knows only key value pairs. It will not as a data type. It knows only the key value pairs. Okay, probably you can join the same meeting whenever it disconnects. Okay, so MapReduce knows only key value pair. Okay, take example of so there is a file called I allow. So like this, some free text is there. Okay, so this is the one file. Okay, so this is a text file. Okay, so when we the MapReduce reads this file, so it can read uh, as a key value pair. Okay, so example, this is being a text file. So in the text input format, the entire line, okay, so it will be taken read. First line will be read. Okay, the offset, see every line has something called the offset, right? So basically the line number. Okay, so line number will be your key and value will be the entire line. So that's how the MapReduce will be able to understand it. It will not understand this is a uh, uh, it's just a file. I have to go on the stream every line and I have to do. So yeah, it's going to read line by line. But what it internally the programming model will understand is everything as a key value pair. Okay, so when it comes to the map phase, it gets only key value. Key as a offset, the line number of the file, and the value as the entire line. So this is a one key value pair, and this will become like key one and value one. So key will be your line number, which is a zero. Okay, zero, and the line is the entire line. Hi everyone. Okay, all right. And similarly, this will be your key two and v2. Okay, which is actually this is line number one. I'm just giving you the simple explanation. Okay, this is how this will be k3, sorry, key 3 and value 3. This will going to be k4 key 4 and value 4. This is how the input will be coming to the map phase. Okay, so so I told you the map phase is basically a kind of transformation phase. Okay, so I can take whenever the data comes. Okay, what the data will come, the key value pair. So I can work only on this data. Every time I can work only on this data. Okay, so I will not know the next line, because it will actually read line by line only. So whatever the key value pair which I get, I can only work on that data. So I'll just do some transformation on this data only, being like simple, like making a case like uppercase, lowercase, or splitting your data, or just substring your data in this line. Everything I can do only on this key value pair every time. So map phase is going to work on this key value pair. Okay, and it is going to write. Okay, as I told you, MapReduce programming model knows only key value pair. It takes key value as input, and output will be a key value pair. Say example, I take this one. Okay, then I am just going to uh, uh, write again. uh, if say example again I want to write, I don't want to do anything, I just want to write it, then I will just say a write of again key and value. So that's how I can do it in the map task. Okay. So when we go to programming, I will explain you with the data types like how it works. But in high level, it takes a key value pair. Okay. So for the input file format, okay, the key value will be line number, and is the your offset is be the key, and the value will be the entire line. Okay. And it actually will write into the disk. Okay. So MapReduce, everything is mostly taking a line from disk and doing some processing and writing the intermediate output on the, it will write on the disk of every slave node. Okay. So here, so in the MapReduce 2, the map task will be running on your container, and it does the transformation and it will write the data into the disk of that particular machine. Okay. And then all your intermediate output will be on every node where the task was running. So then the data will be taken into the where the MapReduce task is running. Okay, it will move from intermediate data which is sitting on the respective data nodes to the data node where the reduce task is running. Okay, during that shuffle, so that is the place time or the shuffle and sort will happen. Okay, so shuffling basically, so if I have only one reducer, so okay, entire intermediate data I have to move it to the shuffle phase. Say example, if I have multiple reducer, right? Multiple reduce. So I told you number of mapper is decided based on the input split or block. Okay, in simple terminology, how many blocks you have, that many number of map task will have. Mapper or map task is same. Mapper is just a class. Inside the mapper class, you will have a map task. So if you have a 4 blocks, yes, I will have 4 map tasks. So reduce task is will be decided by the user. Okay, I can have 0 also, I can have 1, or can have multiple. So if I have multiple reducer, how can I decide which key value pairs has to go to which reducer? Okay, that is decided by, there will be a simple one concept called partitioner. Okay, there is a small check. Okay, what this partitioner does is, it actually takes your key. Okay, and does the hashing. Okay, based on the hashing code. Okay, so example, I have two reducer, so it does hashing, and of so example, when you do hash, say example, so when if you have two reducer, it's a binary, right? If you do hash, if 0 comes, it will go to 0 reducer, first reducer. If when you do the hash on key, if it gets 1, then it will go to the reducer 2. That's how the hash partition works. By default, it works hash partitioner. You can also customize the partitioner so that okay, these are the key value pairs, I have to go to the reducer 1 or 2 or 3, that you can decide based on the custom partition you write. Okay. So MapReduce phase, taking the input as a key value pair and does some transformation and write the data into the intermediate data. So then the data will be during the shuffle short phase, the data is taken and given to the reducer. So in the reducer also, it takes key value pair. Okay, so reducer also will not. So this is in terms of map. So I will just. Okay, so basically, for them. This is our input. Okay, this is the input our to our map phase, sorry, map task, so that the, as a key value pair it will be given. Okay, so we'll start the reduce phase basically it's going to complete this session. We'll again you can connect the same link. Okay, we'll start the reduce phase in the next one. Okay, I'm just stopping it. Please use the same link and connect it again.